Hi everyone, my name is Jordyn Sato and I am a student from the Computer Science Department. I will be going over my capstone project for the Kellogg Honors College, which was creating a game called Isolation with a computer opponent that uses the artificial intelligent algorithm Monte Carlo tree search. The purpose of my capstone was not traditional in the sense that I did research, but instead it was more project based. I wanted to focus my capstone on improving my own software engineering skills and learning a new artificial intelligence or AI algorithm called Monte Carlo tree search. In this video, I'll be going over the basics of this algorithm and then I'll take you through a quick demo of the game. So what is Monte Carlo tree search or MCTS? It's a tree search algorithm that has powered the best chess and Go playing artificial intelligences in the world. I use this algorithm in isolation to determine the computer's next move. In MCTS, there are four major steps when implementing the algorithm: selection, expansion, simulation, and backtracking. In selection, the AI will search the current game tree and recursively choose a child node that is non-terminal and has unvisited children based on a value by something called the upper confidence tree bound algorithm. This algorithm will both explore states that may not be the best move at first glance, but also ensures that we don't underexploit game states that have better immediate child states. Once the computer selects a child state to explore, it moves on to the expansion step. The AI will take that node and determine all the possible next game states and save them as the selected node's children. Then we move on to the simulation or rollout step. The computer will do random actions for each player for each child node. This is where the difficulty of the computer comes in. For an easier computer opponent, the AI will explore only the next immediate move, but a more difficult opponent can simulate up to a terminal or game-ending state. Once it's done searching, it calculates the difference between the number of moves available for each player and saves it. That value is then used in the last step of MCTS, backtracking. The value the computer saved will be used to update all the nodes it simulated through. Once it reaches the root node of the game tree, or the game's current state, the AI chooses the child node that has the best value. The computer will repeat these four steps a number of times, each time it needs to determine its next move. Alright, so let's get into a demo of isolation. So when you first download the game, you'll get this icon. So we'll just go ahead and double click on it to open the game. And we're taken to the main menu. I'll go ahead and click start, and then we'll skip over the directions. You get to choose the AI difficulty here. I'm going to go ahead and pick beginner. And we're taken to isolation game. So the goal of isolation is to isolate your opponent such that they have no available moves left. Each player is initially given a queen chess piece, as indicated here and here. And these pieces move exactly like they would in chess. So you can move any number of spaces horizontally, vertically, and diagonally. Now, the spaces that the player can move to are indicated as lit up, and these grayed out squares that I'm trying to click on, the player cannot move to. So let's say I want to move here. So I'll go ahead and click right here, and you'll see the player now moves to that square, as well as all these lit up squares are now new places the player can move. So you'll see that the computer has also made its turn. Now, you might notice that there are these red X's, and what these indicate is that these squares are now marked as taken, and no player can move back to or over that square. So let's say, for example, I wanted to move here. You'll see that this square is now marked as taken, and the player cannot move vertically up this way anymore because of this taken square here. This means anytime a player tries to make a move, it needs to have a clean line of sight in order to make that move. So I'll go ahead and just lose really quick and get to a terminal state. So you can see here exactly where I lost because the player has no more remaining moves. But you can also see the outcome here. It says computer wins. Obviously, if the player wins, this will be different, but this is what the end of a game would look like. So I have this option to go back to the main menu, and here I can, play another game. I can see the directions again, or I can choose to quit. And that's my capstone project. If you would like to download the game yourself, just go to the release section of my poster, follow that link, and you can download the game there. At this point, I would like to thank my mentor, Dr. Adam Somerville, for guiding me through this, and thank you for listening.